Hi and welcome to my video, the sixth video in the series on graph theory for Year 12 General Maths Unit 4 Topic 2 on Hamiltonian graphs. So we talked about Eulerian graphs in the last video. These are Hamiltonian graphs. Eulerian graphs are graphs where you can travel around or take a walk through the graph and cross through every edge. A Hamiltonian graph is a graph where you can travel around and cross through every vertex. So as you'd expect, there's a slight difference. And these ones are sometimes a little bit harder to deal with. There's not quite so much of a routine in terms of how many, whether the degree of the vertices and stuff as to whether that works. You can't and you shouldn't have to cross over an edge twice, but you can obviously miss some edges out. So we have a Hamiltonian cycle, which is a closed Hamiltonian graph. So if I start at this vertex here, I travel along to there, down to here, along to here, down to here, up to there and back to here. I've gone to every single vertex and I'm back where I started. That's called a closed Hamiltonian graph. Down here, this is my second example, and because I've got this kind of situation here and I can't repeat an edge, I'm dealing with an open Hamiltonian path or Hamiltonian graph. So it's a path around, but I can't close it off. So it doesn't matter where I start. If I start anywhere here, because there's only one degree one now, I have to finish there. But if I start there, I can finish wherever. So let's start here. If I go there, I might go down, along, and down to there. I'm finishing down here. I started there. I've met every vertex, but it's an open Hamiltonian path. And you might find that you go through here and you end up not being able to get back to the start if you take a different route. And so there are open Hamiltonian paths inside here. So this is called a Hamiltonian graph because a closed path or a cycle is available. This one's called a semi-Hamiltonian graph because there's no closed one available, but there is an open one available, so it's a semi-Hamiltonian graph. So Hamiltonian graphs, we have Hamiltonian graphs, semi-Hamiltonian graphs, and it's all to do with meeting all the vertices. All the best.